So the first question about the exam is if we'll be able to go back, pause and resume. You should be able to go back and pause it and resume it, but it has been buggy once in a while. So what I would suggest, if you want to take some breaks once in a while, what I suggest is that you at least record your answers maybe separately, so that you at least know what you answered, just in case it doesn't work out. All right, what other questions do you have? One question was if you can when the test will be online. Probably around noon on Friday, maybe a little bit earlier, probably around noon, and then you'll have till Tuesday to finish it. And one suggestion was that you can do the final as a pair, so you have a partner, a randomly assigned partner. So far, not too many of you have actually been interested in working with a partner. So if you look at announcements a little while back, I posted a little link for you guys to fill out a form. And if you're interested to do that, then let me know. In case you haven't filled out the form yet, but you're interested in collaborating with somebody, let me know. Okay, Ashley was asking about extra credit. So I will post an extra credit assignment. And it's going to be worth 20 extra credits. And I will post it on, I will probably post it on Saturday, on this weekend. So Susie is saying that so far that we have 520 points. I believe, Susie, is that with or without the extra credits? Yeah, so whatever it is at the end, it will be out of, it will be calculated out of 550. So I'll have to figure out that it's really the 520. And sometimes it does include the extra credit in the calculation of the total points, and sometimes it doesn't. So what questions do you guys have as far as the content? How did the regression go? Did everything go well? Okay, so if, excuse me, if you don't have any specific questions, what I'm gonna do is I'm gonna ask you a few quiz questions that'll help you prepare a bit for the final exam. And the first question is this, and I'm gonna post this to the participation link. I'm gonna post this link here. When you look at comparing two groups, for example, two classes, two different classes, Mrs. Hernandez's class and Mr. Hernandez's class, what kind of tests would you use for that? Let's say you're comparing test scores. And, you know, just think about it for a second. I'm gonna post a link. And then you can enter that in the participation meeting. So I'm going to post a link here in the chat room. Or if you have the link from other meetings, you'll just be able to go to the same spreadsheet, but then you move down one sheet. So I'd like you to enter your first name and last name. And the first question is, if you want to compare test scores of Mr. and Mr. Hernandez's class, which test would you use? Right. So I've seen that some guys, some of you have written t-test and some are adding independent t-test. So that's exactly it, right? It's an independent t-test because we have two groups that are separate from each other. So let's go on to question 2. What if you just took Mrs. Hernandez's class, but at the beginning and at the end of a semester? Which test would you use then? Again, using a test score. Paired t-test, exactly right. Why is it paired? Because you have the same group twice. Same class twice, yep. Thank you, Susie. Okay, now let's move on to question 3. If you want to compare self-concept at the end of a year using 3 different forms of counseling, which test would you use? All right, let's assume we randomly assigned people to 3 different groups at the beginning of the semester, then they went to counseling, and then at the end of the semester looked at their self-concept. Which test would you use to compare their self-concept? Okay, great. ANOVA, right? Why would you use ANOVA here? Right, it's a great job because you have more than 2 groups, right? Question for everybody. Could we answer this question by using a t-test? Could we use that t-test? Right, because just to backtrack a little bit, right? T-tests we're using when the dependent variable is on a interval scale, at least, so we can calculate means. And our independent scale is a nominal scale or an ordinal, right? We create groups with the independent scale. We look at different groups, and then the thing that we're looking at, the dependent variable, is on an interval scale. So that's what the t-test and ANOVA have in common, right? They're both of them have as a dependent variable, they have an interval scaled variable, and the independent variables are nominal or ordinal scaled. So we could use a t-test if we had more than 2 groups, right? We could use a t-test for group A and B, A and C, and then B and C. But what would be the problem? So I'm going to let's make this question 4. What would be the problem with doing a t-test with more than 2 groups? What could be the issue there? Right. You'd have an accumulation of the type 1 error, right? Each time we do a test, we have the 5% versus 95%, right? We always have a 5% chance of making a mistake. And if we do the same test multiple times, we multiply that 5% every time. Okay, now Q5, question 5. If you want to predict the GPA at the end of a semester with the SAT at the beginning of the semester, which method would you use? Ah, okay, so this one, let's talk about this one a little bit. Can you ask me some questions? Does this one seem a bit confusing? Right, that's we're trying to predict something, and the regression is our method to predicting things, right? So we're trying to figure out that things that go together that are correlated, right? If we regress one on the other, we can try to predict it. So you can imagine if you know that somebody has a high SAT score, likely will have high GPA scores as well. All right, so that's the principle of the regression. Do you have questions about that or comments? All right. So question 5 would be, if you want to predict the GPA at the end of the semester with the SAT from the beginning of the semester, you could use a regression. And let's go to the second to last question. Sorry about that. Who knows the movie Deuce Bigelow? Who's seen that movie? It's a really stupid movie if you haven't seen it. Has anybody seen it? Yes, Deshaun says yes, it is. Okay, all right. That's as far as we need to go. All right, it's a dumb movie. So let's say that I love Deuce Bigelow, and now I'm kind of considering to watch Shining, but you know that Deuce Bigelow and Shining correlates with negative 0.6. Would you recommend that I watch Shining? All right, let's say you're that little human robot in the Netflix engine, and you have to decide, oh, should we recommend Shining to this guy or not? Should I watch Shining or not? If you know that I love Deuce Bigelow. All right, Deuce Bigelow, it's a funny movie, it's a dumb movie. I don't know if you've seen Shining. It's more of a horror movie, right? It's scary. I know intuitively, you know that. Right? You don't know, right? Some people like Deuce Bigelow and they like Shining, but just based on that, these two are not really. There are different types of movies, different kinds of movies. You would not recommend. Okay, now another question. If you are tasked to study the police records of Fresno, and you're looking at how often are different ethnicities stop in a traffic, just in a control, right? Police are looking at somebody, then they stop them and investigate. And you're looking at, the percentage of each ethnicity being stopped. And then you look at the percentage of the population, right? So let's say, 40%, I'm just making this up, right? 40% of Fresno residents are white, 10% are African American, 20% are Asian, and let's say 20% are Latino, right? Again, just made up numbers, right? You have some percentages of different ethnicities, and then you look at the police records and you see they stop 30% of Asians and they only stop 10% of whites, and they stop 30% of their stops involve Latino people, and 30% African American, right? So you get two different percentages. Which test could you use to figure out if maybe one group is overrepresented in the police records? Right? So let's just assume if 10% of the population is African American, and then you see that actually the police stops 20% African Americans, you'd say, well, it shouldn't be, if everything was equal, shouldn't it be about 10% as well? So there's actually a statistical test that you can use to figure out if that distribution, if the sample of the police is higher than expected, right? It could be normal to have maybe 12% African American or 8%, right? If you look for 10%, but let's say it's 15, 16, 17, 18, or 20%. When will we say, you know what, there's a statistically significant difference between what we observe in the police record and what we would expect based on the population numbers? Which statistical tests could you use there? Right, so now we have a dependent variable that is nominal, right? The ethnicity, it's categories, right? It's nominal. And the independent variable is also nominal, right? With two, we have categories in what is observed by the police and categories of what is expected based on the population. And when we compare that, we basically compare how many do we have in each category. Does that match up? And as an example, for example, would also be if you look at a dice, for example, right? If you know that the dice has 6 sides, you would assume that each side is going to show up 1/6 of the time. So here it's the same thing. I'm sorry, this disappear here. So again, let's say you had a distribution of ethnicity in the sample, right? The police stop people, and you know there's a certain distribution of ethnicities where they stop, right? They might stop, of all the people that they stop, maybe 40% are white, 10% are African American, 30% are Latino, and 20% are Asian. And let's say in the population you have 10% Asian, but you see that the police actually stopped 20% Asian, right? So there's this discrepancy between these two. So you have categories in the dependent variable and categories in the independent variable, and you look at these two and compare them. Which test could you use to see if the distribution within the observed data or the police stoppages is different than the distribution within the population? All right. So we have a good guess there. Susie is saying chi-square. Marissa saying correlation. Actually, correlation kind of makes sense as well. You're comparing two variables, but because both of these variables are nominal scale, right, or categories, we're comparing, do we have the same amount in each category, or basically do we have the same distribution within the observed data and the expected data. So we expect a certain distribution based on population, and then we look at, well, who did the police actually stop? And if this doesn't match up, then we have a statistically significant difference between observed data, the police stops, and expected data, the population distribution. Okay, so this is basically a little turn. We have one more. Let me ask you this. Which test did I not ask you about? And then you could say, which chi-square is it in question 7? Is it the goodness of fit test? Is it the goodness of fitness? Yes or no? Or is it the test of independence? This here is the goodness test. Is the chi-square. And which test did I not ask you guys about? I asked you about the chi-square, but specifically I did not ask you about the test of independence. And Susie asked earlier about what is the difference between correlation and regression. And that is a very good question. So that's going to be question number 9. What is the difference between regression and correlation? Well, okay, why is question number 7 test of the goodness of fit? It's because we have a distribution from the population, right? That's what we're trying to match. And then we compare whatever we found with that distribution, right? Imagine if we had a dice that we would roll and it had 6 sides, we expect 1/6 for each side. So the same thing we can assume for population, right? We know, oh, we gotta have 10% Asian, 20% African American, let's just say, 20% Latino, 50% white, whatever the distribution might be in the region that we're in. That will be our comparison, right? And then we look at how well does whatever we find fit that comparison. But what we could do, for example, for it to be a chi-square test of independence, if we looked at gender and ethnicity. So we could ask, hey, do the police stop African American males more often than African American females, right? We could look at, is there a relationship between gender and ethnicity? We could look at that. And the difference between regression and correlation, what's the difference? And guys, that's going to be the last question for tonight. If you guys don't have any more, I think that's a very good question. What's the difference between regression and correlation? Just to not to confuse you guys, they are very similar. Right? So that's a great question. They seem similar. What's the difference here? Oh, that's an awesome answer. Marissa, great answer. Correlation looks at the relation between two variables. Regression is trying to determine, to predict one value with the of not variable. That's an awesome answer. And so here's this. If you only have one predictor in the regression, they're actually quite similar. Right? Because remember, we use the correlation between one and the other as the beta, as the slope. Right? So the regression coefficient becomes, the correlation becomes a regression coefficient in the regression equation, plus then we have an intercept as well. Right? So if you only have one predictor, they're actually quite similar. But then what you can do in a regression, and we didn't really go too much in detail on that, you can add more predictors to a regression. So then the correlation just has one relationship, right? There's just a pairwise correlation, or the regression can involve multiple predictors. And what happens then to well, let me give an example. If you're trying to predict the final grade with a SAT score, If you just have that, then the slope of the SAT score, the regression coefficient, is going to be the same as the correlation between SAT and the final grade. Now, if you say something else, if you say, you know what, it doesn't just depend on what kind of SAT score people have, it also depends on the degree of effort that people put in, okay? Then we have two variables to predict the GPA. We have the SAT, right? How much they knew at the beginning of the year in the SAT score. And then the second predictor will be the effort. So now that correlation between SAT and GPA gets adjusted for the degree of effort. Right? So then the correlation between the GPA and the SAT is not the same as the slope between the SAT and the GPA when controlling for effort. So I hope that somehow made sense. Great. So, so I hope these kind of quiz questions kind of helped you, get an overview of what we talked about. Questions on the quiz are going to be around that, which test would you use? You're going to have to do some calculations as well. But most of this or everything that I'm going to ask you, you will have done already. Okay. Okay, do you have any questions or comments? If not, I would say we leave it at that. I hope it was helpful to kind of go over it again. You kind of have to think through the different methods, see which test do I use when. That's a normal, how can I say, that's really when you develop some more knowledge of the statistics, right? Now you used all these tools and questions. Okay, which tool do I use when, right? And that takes a little bit of practice. Down the road when you guys do statistics, when you're like hesitant, or which test should I use here? Ask a colleague or get in touch with me. That's fine. I'm always here to. I'm always interested to hear when you guys use statistics and how it becomes meaningful to you guys. Like, how is it useful for you? Okay, any questions or comments? All right, if not, I don't see anything in the chat. If you had something, I don't see it. Ashley, there will be no time limit on the final. It'll just be open for 4 days. I try to make the test, the test should be easily doable in 2 hours, easy. Okay. But if you want to take more time, that's fine as well. Okay? But I'm really conscious that you guys got a lot of other things going on as well. So I don't want for you guys to have to do too much, spend too much time on it. But if it takes you a little bit longer, or you really want to make sure that you give the correct answers, that's fine as well. Okay, any other questions? All right. If not, then I'll wish you a great evening, and I'll send out a message as soon as the test is up, and I hope everything goes well. And then also I'll offer a session after the test where we can talk about what went well, what didn't go well, and just make sure that the test itself should be another learning experience for you guys, right? Just kind of solidify whatever we talked about this semester. All right, great. Okay, have a great evening. There will be one attempt. Probably just I'm probably going to have it open for 2 attempts just in case something goes wrong with the first one. But really, it's just one attempt. All right. Have a good evening. Bye bye.